Yogah Karmasu Kaushalam.
Good afternoon, participant. I am Dr. Mamta Brahmbhatt, Associate Professor from BK School of Business Management, Gujarat University, welcoming you all again in the second portion of the first session of mine, that is hypothesis testing. In the previous session, first part, we have discussed the difference between the descriptive statistics and inferential statistics. What is the difference between population and sample? What is population parameter and sample statistics? What is sampling? What is data? What is variable? Types of data, types of variable, how different variables are used in the research, what is hypothesis. In this session, second part of this session, I will be discussing the terminology which is used in the testing of hypothesis. So let us start with the today's session. For that, I need to share the screen. Allow me a second for that. In today's session, I am going to cover concept of hypothesis testing. What are the learning objective of this session? Upon completion of this session, you will be able to understand the difference between null hypothesis and alternative hypothesis, how type 1 and type 2 errors are different with each other, understanding the concept of one-tail and two-tail distribution, and understanding the procedure of hypothesis testing. Let us start with the null hypothesis and alternative hypothesis. Hypothesis testing can be used to determine whether the statement about the value of population proportion or population parameter should or should not be rejected. So null hypothesis, it is denoted by H0 and it is an assumption about the population parameter. Now in the previous section, I have covered what is population parameter. Whenever you are doing the null hypothesis, we are making the assumption about the population parameter value. Say for an example, in this online faculty induction program, there are 5,000 faculty enrolled. If I want to compare the income levels of these faculties, then what hypothesis I can write? I can write the income of this group is 50,000. What is this 50,000? Is it calculated value? No, this is assumed value. I'm not going to conduct the survey of all 5,000 respondents, and that's why I have assumed one number, and that is 50,000. So this 50,000, it is mu, which is population parameter value. So this population parameter value, it is assumed value. I am going to compare this value with the sample statistics. So out of this 5,000 enrolled participant of this Guru Dakshita program, I will take only 10% of that, that is 500. Out of 500 faculty enrolled for this, I will conduct the survey and I will calculate their average income, which is X bar. Yeah. So this X bar, it is calculated. The number which I have assumed in the beginning, it is the population parameter value. Population parameter values are always unknown because we are not going to conduct the population study. We are always doing the sample study, and that's why the sample statistics are known to us and population parameter values are. The null and alternative hypotheses are mutually exclusive. Only one of them can be true. So if I'm saying that the null hypothesis, it is assumed to be true, the alternative hypothesis, that is false. So null hypothesis, we are always testing for the possible rejection. The burden of proof of this falls on the alternative hypothesis. The theoretical definition of null hypothesis is there is no difference, there is no change, there is no correlation, there is no influence. That means there is no difference in the status quo that considered is true unless and until it is proved wrong by the collected sample. So null hypothesis, it is nothing but it is tested for possible rejection. Now what is this possible rejection? Whenever you are starting a research, you need to set the hypothesis as if you want to reject it. Take the example that whenever the R&D department of any pharmaceutical company inventing a new drug, they start with the assumption that this particular drug is not at all effective. With that assumption, they are testing this particular drug on animals, and then the next day headline you'll find in the newspaper that this particular drug it is effective because it is not harming the animals. So what the result they want? They want drug to be effective. So opposite to that, they have set the hypothesis that drug is not at all effective. So another definition of null hypothesis, you can say that what result you want to get it out of your research. Opposite to that, you need to set the hypothesis. Yeah. So you need to visualize your outcome and what will be the probable outcome of your research. Opposite to that, you need to set the null hypothesis, and that null hypothesis you need to reject. Clear? So null hypothesis, it is always tested for possible rejection. The alternative hypothesis is opposite to null hypothesis and it is denoted by H1. Null hypothesis it is denoted at H0 and alternative hypothesis it is denoted at H1. So alternative hypothesis it is researcher claim. When null hypothesis is found to be true, the alternative hypothesis must be false. Or when the null hypothesis is found to be false, the alternative hypothesis must be true. So null hypothesis it is always tested for possible rejection and alternative hypothesis it is a researcher claim. In earlier days in research, we used to write the null hypothesis, but now the new fashion is that researcher they report their alternative hypothesis in the document. What is level of significance? If I have to talk to a layman, then I can say that level of significance it is nothing but it's your confidence level. How much you are confident about your research that signifies the level of significance. So when I'm saying that 5% level of significance means 95% I'm very sure about everything which I'm doing in my research and 5% there are chances of error. This level of significance it is generally denoted as alpha. It is nothing but it is a probability which is associated to null hypothesis which we rejected when it is true. The level of significance is also known as the size of the rejection area or the size of critical area. Now, what is rejection and critical area that I will be covering very soon. The level of significance, it is normally applied by the researcher at 1%, 5%, and 10%. Level of significance, it is associated with the level of risk. Oh, higher the risk, low you can lower down your level of significance. Yeah. So if the risk involved is very high, then you can keep the level of significance at 1%, and you have to be very sure that 99% you have to be confident. Yeah. So let me repeat one more time. If associated risk with your research it is very high, you need to keep the level of significance at low level. Social science researcher, when they do research, there is no risk involved. Clear? Because maximum time, all the time, we are studying attitude, perception, habits. So this all things are not having any direct impact of risk on the respondent. So that's why we are keeping the moderate level of risk, that is 5%. One more time I'm repeating, level of significance, it is nothing but your confidence level, your confidence interval. Clear? Your confidence, how much you are confident about your research. When I was saying that 5% level of significance, that means 95% you are confident about everything which you are carrying on for your research, and 5% you are assuming there are chances of error. Level of significance you can relate with the amount of risk. If risk involved is very high, that time you can keep the level of significance low. So when I'm assuming 1%, that means 99% I'm sure. And that's why I'm keeping 1% level of significance. Now, what is two-tailed distribution and one-tailed distribution? Or what is two-tailed test of hypothesis or one-tailed test of hypothesis? Two-tailed test contains the rejection area on both the side. Yeah. So when you draw the normal distribution curve, your rejection area falls on the both the side. That is on the right hand side and left hand side. This means researcher will reject the null hypothesis if the computed sample status is significantly higher or lower than the hypothesized assumed population parameter, considering both the tail that is right as well as the left tail distribution. Take this example. This shows the acceptance and rejection areas of null hypothesis under the two-tailed distribution. Yeah. So this is the normal distribution curve. I am assuming that the level of significance is 5%. So this entire left hand side area, it is 50%. This right hand side area, it is 50%. This 50 and this 50, it is 1. So probability ranges between 0 to 1. On left hand side, it is 50% observation. On right hand side, it is 50%. When I'm assuming that level of significance is 5%, that means 95% confidence. 5% there are chances of rejection. So this 5% I need to divide by 2, which will come 0.025. This is percentage and that's why 0.025. So 0.025 on this side and 0.025 on this side. So when you have a two-tailed distribution, your hypothesis will be rejected from both the side, that is left hand side and right hand side. This 50%, this entire area, you know it is 50%. 0.50 minus 0.025, you will get 0.4750 on left hand side and 0.4750 on the right hand side. This is nothing but these values are captured from Z normal distribution table. So if you see this nearer value of Z distribution, you are getting 0.4750. So corresponding Z scale score you are getting, it is minus 1.96 and plus 1.96. Yeah. So when you are having a 5% level of significance, your hypothesis will be rejected from both the side. Left hand side the half percentage and right hand side the half percentage. When I'm saying that the income of this group, it is 50,000. Clear? So that is the assumption. This assumption will be rejected from both the side. People, those who are earning below 50,000, they will reject my hypothesis from left hand side. And people, those who are earning above 50,000, they will reject my hypothesis from the right hand side. Yeah. So two-tailed distribution, my hypothesis will be rejected from both the side. So this is called rejection area and this is called acceptance area. One-tailed distribution or one-tailed test of hypothesis. One-tailed test contains the rejection region only on the one side. In case of the left-hand side distribution, a researcher rejects the null hypothesis if the computed sample statistics is significantly lower than the hypothesized population parameter value. In case of the right-hand side distribution, the researcher rejects the null hypothesis if the calculated sample statistics is significantly higher than the assumed value. Observe this graph. Acceptance and rejection area for one-tailed distribution, and that is on the left hand side. Again, I'm saying that the 5% is the level of significance. When I'm saying the 5% level of significance and my distribution, it is a left hand side distribution, this entire 5% will fall on the left hand side. So this left hand side area, you know it is 0.50. 0.50 deduct 0.05, you will get the 0.45. This is the nearer value you have to capture from the Z distribution normal distribution table. So you'll get the minus 1.645. Why it is minus? Because it is a left hand side distribution. So in the one-tailed distribution, my hypothesis will be rejected only from a one side. If it is a left-hand side distribution, my hypothesis will reject from left side. This is the right-hand side distribution. The similar thing I have done. My hypothesis, it is rejected only from one side, and that is the right-hand side. So entire level of significance 0.05, I am placing on right-hand side. If I am deducting this entire area of right-hand side, it is 0.50. If I deduct this 0.05 from this, it is 0.45. You can capture this nearer value from the Z distribution and you will get the positive 1.645. Yeah. So when you have a right hand side distribution, your hypothesis will be rejected only from a right side, and that time there is no need to divide the level of significance by 2. In the previous example, when my hypothesis it is, or when my distribution it is a two-tailed distribution, this 5% I have divided on both the side. So that's why it is 0.025 and 0.025 on this side. But when it is a one-tailed distribution, entire 0.05, it will be on the left hand side or it will be on the right hand side. What is type 1 and type 2 error? When you are conducting the research, there are chances of error. Yeah. There are chances of possible outcomes. What will be the possible outcome? The possible outcome when you are conducting the research could be of four types. Rejecting the true null hypothesis, you are creating the type 1 error. Accepting the false null hypothesis, that is type 2 error. Accepting a true null hypothesis, that is correct decision. Rejecting the false null hypothesis, it is a correct decision. Type 1 error, when you do research, there are chances of error. And this error, as a researcher, you need to minimize. So type 1 error, it is nothing but you are rejecting the S0 when it is true. The probability of committing the type 1 error, it is called the label of significance, which is denoted by alpha. Type 2 error, a type 2 error is accepting the S0 when it is false. The probability of committing the type 2 error, it is called beta. So type 1 error, it is alpha. Type 2 error, it is beta. It is difficult to control the probability of making the type 2 error. And that's why the statistician, what they do, they avoid the risk of making the type 2 error. They say that do not reject S0, not accept. Yeah. So you will never find any book of statisticians saying that accept the alternative hypothesis. Do not use the word accept null hypothesis. We are writing do not reject S0. Yeah. So writing accepting the null hypothesis is a wrong terminology. So do not use accepting the null hypothesis in your PhD or MPhil documentation. Rather than saying accepting S0, you can say that do not reject S0. Now, all my students of MBA, they are creating this two type of error, type 1 error and type 2 error. Now, when I'm teaching the quantitative techniques in the first semester to MBA student, what perception they are carrying about the subject MBA, what they are discussing, they are saying that, yeah, Mamta madam के class में कितना मजा आ रहा है. Madam is introducing the subject. Madam is introducing the concept. The how to calculate the sum, it is covered in detailed manner. Things to remember, it is provided. Many managerial implications are discussed along with the theoretical framework. And previous year's papers are also discussed. So perfect method of teaching. Not, we need not have to do anything. This is students' opinion. Clear? So when I'm teaching quantitative analysis, that subject itself is so heavy and there are chances of failure. So I'm not allowing any student to make the presentation and everything I am doing by my own. So sometimes it is not spoon feeding, but sometimes I'm saying that I'm chewing some portion on behalf of my student, that giving even the answers of the previous question paper so that the failure rate can be reduced. Now, this method of teaching, it is actually wrong. Clear? This method of teaching to MBA student is just not perfect. The student accept this. You see the IMs, they are not teaching this way. But I am teaching this way because I do not want to increase the failure rate of quantitative analysis subject in my class, in my course. And that's why I am following the method which is highly appreciated by the student, but that method, it is false. Clear? That method, it is not correct. So the thing which is false, students should reject that. But here, the students accept the things. They are creating errors. Clear? When the same set of students, when they appear for the third semester, in third semester I am teaching strategic management. So in the strategic management, they need to make presentations. And I am giving the presentation in such a way that Google Baba will not help them out. What I'm asking them, you need to study the organization structure. And if they have to study the organization structure, I am giving that what they need to study. So I am assigning them, you need to study the police department. Go to police department, take the interview of police, learn their role, responsibility, authority, boundaries, and relate with the strategic management. When I'm giving this kind of a presentation to the student, it is nowhere available in Google, and that's why they need to do a lot of brainstorming analysis and session with their fellow participants. And that time, students say, In first year मैडम कितना मजा से पढ़ा रहे थे, no presentation, no quizzes, nothing extra. But now in the second semester madam has changed. In third semester lot of burden of the subject, lot of presentation, we need to make it. This method of teaching it is correct, but again students they reject. So all my MBA students, they are creating this two type of error when they are studying in the my MBA program. Now, let us take one more example to clarify the type 1 and type 2 error in detail. Now, I have given here four situations that diseases were there and doctor has identified that is what. Clear? There is a disease and doctor has said that yes, there is no disease, or there is four combinations are given. Clear? So here person or the people has not got any disease and the doctor has correctly identified it is correct decision. Clear? Here the disease were there and doctor has identified, yes, you are suffering from so and so disease. So this is the correct decision. Now doctor can make two type of error, type 1 error and type 2 error. And how these errors are risky, let us check this. Say for an example, the disease were there here. Yeah, I was suffering from something. XYZ person was suffering from something, but doctor is not able to diagnose that particular disease. Let me take the example of my own family. My mother-in-law, she was suffering from cancer, but in the earlier stage, when we have consulted doctors, doctors told that yes, there is no disease because there was the small and there was the problem in the small intestine, the small tissues in the small intestines that was created, and doctors or the X-ray report is not able to diagnose this cancer in the initial stages. Yeah. So when disease was there, and doctor has not identified, not diagnosed this properly, doctor has created the type 2 error. So when you are creating a type 2 error, it is a loss to a human. Clear? So that case, it is gone. That case, it is expired. So when doctors has created a type 2 error, it is very risky. Take the another example. I'm relating same with my example. The similar way in the 2015, I was also suffering from a stomach pain. So when I told my husband that there is some pain in my stomach, in what doctor has suggested, in the previous cases there was some mistake. Now I don't want to take a risk. You go for CT scan. Yeah, so doctor has suggested us to go for CT scan. CT scan cost around 15,000 to 20,000. So this time also doctor has identified, yes, this time also the doctor has created a error. The doctor has committed the mistake. There was no disease, but he thought that it could be clear, and that's why he has suggested for going for a test or CT scan. So both the cases, doctor has created an error, and this is type 1 and type 2 error. In the first case, when doctor has created a type 2 error, it is a loss of life. Yeah. When doctor has created a type 1 error, it is just a involvement of 20,000 to 50,000 cost of CT scan. Yeah. So when you are committing the type 2 error, it is irreparable damage. But when you are committing the type 1 error, it is treated. But there is no harm. You can go for the type 1 error, it is allowed. So if you want to reduce this errors, you need to keep the level of significance accordingly. Now, the last topic of today's session, it is hypothesis testing procedure. These are the 7 steps the researcher can follow for testing the hypothesis. The first, it is the setting the null and alternative hypothesis. Keeping in mind your research objectives, you need to set the null and alternative hypothesis. Don't copy directly the null and alternative hypothesis from literature review or from previous papers. If you are copying, then it is not the deciding the null and alternative hypothesis. Null and alternative hypothesis should be decided on the basis of your research objective. Second step, in the second step, determine the appropriate statistical technique you want to apply to your data. Say for an example, if you have two questions and both the questions are categorical in nature, then you can say that the appropriate statistical technique you are going to use it is the chi-square or cross steps. Okay. Determine the level of significance. For social science researcher, I'll suggest that 5% level of significance, it is the medium moderate level of significance, or the risk involved it is moderate, so you can keep the level of significance as 5%. Collect the sample information or the sample data. Decide your sample size, decide your sample technique, decide your sample unit, collect the information. Now compare your collected data with the hypothesized value, analyze the data, make the conclusion, and discuss the business implication for that. So this is about the testing the hypothesis process. Now it is time to recall the session. In today's session, I have covered what is hypothesis, what is null and alternative hypothesis, what is one-tail and two-tail distribution, what is type 1 and type 2 error, and what is level of significance. Hypothesis, it is nothing but the assumption. What is null hypothesis? Null hypothesis is opposite to your research outcome. Null hypothesis is opposite to probable answer of your research. Yeah. It is always tested for possible rejection, so do not use the word except here. Opposite to null hypothesis, it is the alternative hypothesis. When your hypothesis is rejected from one side, it is called one-tail distribution. When your hypothesis is rejected from both the side, it is the two-tail distribution. Type 1 and type 2 error, it is the, whenever the researcher they are doing the research, the probability that you may commit the mistakes or error, type 1 and type 2 error, you should try to minimize. Level of significance, it is nothing but the, I will say that the, what is the confidence level. Yeah, the amount of a confidence or the level of the confidence with which you are carrying your hypothesis or entire research journey, it is level of significance. So with this, I will end the first session's second part of this hypothesis testing. In the next video, we'll start with the introduction of the SPSS software, how to enter the data in the SPSS software, what is variable view and what is data view. Everything will be discussed in detail in the third video of this session. Thank you so much, participant. Have a nice day.
थैंक यू ममता ब्रह्मभट्ट जी, आपने अपने कीमती समय को हमारे साथ संजोया है। आपके इस सेशन से मुझे पूरा यकीन है कि हमारे पार्टिसिपेंट्स को कुछ न कुछ सीखने को मिला होगा और आपके इस अनुभव के निचोड़ के तौर पे आपने अपना व्याख्यान जो हमें यहाँ दिया है वो पूरा, हालांकि इस कोविड-19 की सिचुएशन में अभी ये वन वे कम्युनिकेशन जैसा लगता है, लेकिन ममता जी की जो स्टाइल है उससे मेरे ख्याल से आप हम सभी को ये टू वे कम्युनिकेशन जैसा फील 100% आया होगा. So I'm really thankful to Mamta Brahmbhatt ji for this wonderful lecture. On behalf of HRDC गुजरात यूनिवर्सिटी, ममता जी, मैं आपका अभिनंदन करती हूँ, धन्यवाद करती हूँ और हमारे गुरु दक्षता प्रोग्राम के सभी पार्टिसिपेंट्स का भी तहे दिल से हार्दिक अभिनंदन करती हूँ और सबका धन्यवाद करती हूँ. फ्रेंड्स, जैसे कि हमें पता है अभी कोविड-19 की सिचुएशन में हमें इस प्लेटफॉर्म में ही मिलना है और हम ये डिजिटल प्लेटफॉर्म से ही हमारी ये टीचिंग लर्निंग की जो जर्नी है उसको हम आगे बढ़ाने का ये हमारा HRDC गुजरात यूनिवर्सिटी का सर्वप्रथम प्रयास है. ये पूरा प्रयास हमारे डायरेक्टर प्रोफेसर डॉक्टर जगदीश जोशी जी की गाइडेंस में चल रहा है. हमारी पूरी टीम HRDC की और हमारा टेक्निकल सपोर्टिव जो हमारी सिस्टम है उन सभी का आज मैं धन्यवाद करती हूँ मेरे कलीग प्रोफेसर सीजी ब्रह्मभट्ट जी और हमारे जो भी सहायक बने हैं इस कोर्स को अब तक पहुंचाने में, उन सभी का मैं HRDC गुजरात यूनिवर्सिटी की ओर से धन्यवाद करती हूँ। थैंक यू वन एंड ऑल।